Hi everyone, welcome to today's webinar. We will be recording the webinar and it should be available afterwards. We'll share by email afterwards. Please feel free to ask questions in the Q&A tab. We will, in the course of today's chat, we will answer them throughout this webinar. So with that said, let me introduce myself. My name is Krishnaram Kentapadi. I'm the Chief AI Officer and Chief Scientist at Fiddler. So I have been at Fiddler for a year. Before Fiddler, I was part of the AWS machine learning team and also LinkedIn machine learning team. In both places, I drove and led the responsible AI related efforts. Today with me, we have Goku Mohandas, who is the founder of Made with ML, as perhaps all of you are familiar. Goku, would you like to introduce yourself?
Yeah, sure. We'll get into the details later as well. But hey, everyone, nice to meet you. Background, school, everything's in sort of biology and chemistry world, which kind of spending half my time on these days, and great synergy with ML as well. Yeah, worked at Apple for almost 3 years, mostly mixture of NLP and the early stages of ML platform there. Then went back into health, left with the head of Apple Health to start a company in the oncology space where first ML and also led the machine learning team there. And I had this context of applying machine learning in different, let's call it scales and maturities and certainly applications. So that's when I started Made with ML. And we'll get into the details, but I basically started that to just teach my view on and my experience on putting ML into production. But I've been learning so much from other people as well. So yeah, I'm excited to be here today, and I'm excited to talk to Krishnaram specifically because, ML has become hot maybe the last 10 years or so, but folks like yourself have been working in this space long before it was called these things, and even some of the more downstream workloads like monitoring and responsible AI for such a long time. So excited to learn more from yourself, and yeah, thanks for the Fiddler team for having me today.
Thanks, Goku, and thanks for joining us today. Maybe I'll just start with a little bit anecdote. As you mentioned, I brought up this ML, right? So several years back, when I was doing my PhD at Stanford, I instructed a course on artificial intelligence over a summer. Looking back, I can't even imagine that's how the course was. The course was, the title was artificial intelligence, but there was hardly any mention of machine learning. It focused more on things like path planning, A-star algorithms, search algorithms, and so forth. So things we have, I think, both in academia and in industry, we have come a long way since then, right? So this is almost 15 years back. All right, so let's start with, so you briefly touched upon Made with ML, like maybe for those who may not be as familiar, can you just describe what Made with ML is and why did you, what inspired you or what motivated you to create Made with ML?
Yeah, absolutely. So as I mentioned, it's two different contexts, scale, maturity, application. And those are just two views, right, on what putting machine learning into production looks like. So it actually started, I guess, 2016, where I had model-specific content. So I think it was like TensorFlow 0.5, one of the first places you can go to not just see the neural net code itself, but actually be able to connect it with data pipelines and deploy it. Very crude manner, but that's how it started. And I did the last 3 years or so, it's been almost entirely on the model agnostic pieces. And I try to make it as tool agnostic as well, but that's hard to do because there are a lot of amazing tools in this space. But yeah, I tried to make it scale agnostic, model agnostic, and just focus on core principles. And I personally, the motivation to start this was, one, it's a lot of material. So I knew it was something that I would go back to all the time to refer to. But I wanted people, it's a little bit better after COVID, but there's still these remote silos in geographical hubs in the world, basically, where you have the opportunity to work with a team who has resources and who's putting ML in production large scale. And I wanted people around the world to be able to kind of learn this stuff. And at the same time, like I said, I only have these two contexts, and there are people around the world who know way more about these topics than I do. So I wanted to put this out there to attract those folks as well. So I've learned a lot. I would argue I learned more than the past two jobs and the work that my actual day job now that I do through this medium. just because you meet people from different industries who are trying to use this tool, right? It's not an industry. ML is a tool, and it's a way of thinking. And I've just been very privileged to learn from others through this as well. But yeah, that's the main motivation, and it'll always be free, and I'll continue to keep it up to date. And yeah, hopefully it becomes easier to do this stuff too.
Yeah, that's a great inspirational story. So maybe on that note, like amongst the ways in which people have benefited from Made with ML, right? Did you come across anything which was very surprising, or like people using the Made with ML in a way that perhaps you may not have even thought of?
Yeah, and I think it speaks to maybe the maturity of the industry right now. So obviously I have access to um, what lessons or what pages get the most traffic and how much time people are spending, and even like specifically what section people are spending time on. And I always thought, people would be coming in to take the whole course. Maybe they'll start it, hopefully they finish, but maybe they won't. But after the homepage, actually, the top lessons are not in chronological order. So after the homepage, because that's the entry point, people, the next biggest one is testing machine learning.
Mm-hmm.
The one after that jumps immediately to monitoring machine learning. And then after that, it's like data stack for ML, et cetera. So these are I would argue middle or very much downstream workloads, MLOps workloads that people are coming in. And it could be a mixture of, obviously people have some systems at work and they're wondering how to kind of implement and learn about these more downstream workloads that they may not have already, which is great because I think it speaks to the maturity of the industry. But yeah, I wasn't expecting that. I thought people would just go through in order, but no, people are definitely coming in with purpose, and hopefully it fills in a few of the gaps for them.
Yes, I think that's really interesting because as someone hosting the content, right? So you get a feel for which parts of the content are getting a lot of traction, right? Like maybe that may be different from the way we may anticipate it, that people will learn in a linear fashion, right? So on that note, so if you think of the MLOps pipeline as a whole, what do you think are some of the crucial aspects of this pipeline which are perhaps neglected a little bit or underserved, and why do you think so?
Yeah, maybe before getting to MLOps workloads, I'll just quickly make a note on the whole design and product and motivation around ML, which I think I just scratched the surface on, and there's just 3 lessons if you notice on the design aspect. But knowing when to use machine learning, justifying the use of machine learning, being able to break like a large business goal into different applications, and they each have quantitative kind of metrics you're trying to optimize for. So this whole art around design and product is a big piece. I don't think we'll get into the details of that today, but I just wanted to say that's definitely something that's evolving and is definitely underserved. And a lot of teams, can spend a lot of time, wasting their efforts and not really getting the ROI. So I think I'd love to talk about that later. But in terms of specific MLOps workloads, maybe I'll try to go in chronological order, which is actually slightly difficult, right? Because the course is chronological, but these concepts, you apply them cyclically. Like you don't just monitor once, you don't just test once and drop. Every time you make updates, you have to kind of do these things. So that was a little bit of a challenge when it came to teaching something cyclical in a linear fashion. But let's say first pass, something super surprising, Krishna Ram, was everyone knows about experiment tracking. And let's call it experiment management, or just, and when I say that, experiment plus artifact management. Everyone knows about it. Everybody understands why it's important. But I think, especially 3 years ago, when I started to talk about this stuff, and a lot of people were at that time as well, and these tools were coming out, I think most data science teams in the corporate setting, regardless of kind of the scale of the larger company, there's a lot of collaboration around when it comes to what should we build, what products, et cetera. But then when it comes time to the application, you have these silo or solo data scientists. And it's either 3 or 4 data scientists working on the same project, but they're all doing their own little approach, and there's not much collaboration. Or I would argue even worse, each of the 3 or 4 data scientists in the team, they each own a completely different project, and the idea is they don't have to collaborate. So something like experiment management, and I ran a survey, I guess maybe just 8 months ago, with around 100 people from different companies around the globe. And a very shocking number, right? That less than 10% were actually using some kind of experiment management platform. And it just boiled down to the way they were working. But I think it's changing now. I think as these tools make it a little bit easier to, let's just call it, right, the main point of these tools is for reproducibility, to be able to track all these things. So even for the solo data scientists, there's becoming a more and more of an incentive to use these tools and follow these practices properly, even before you have enough critical mass that there's collaboration even within the context of a single project. So yeah, experiment tracking was definitely a shocking one, because you just assume people are doing this in some way, or even some old trivial way where they're using TensorBoard and storing files or something. But yeah, I think even with the tools, we're in the early stages of adoption for those tools for sure.
Yeah, this reminds me of an incident several years back, right? In the early days of machine learning, what would happen is that each engineer or the data scientist would train some recommendation model or ranking model on the desktop, and there are situations where we had the final trained model which was deployed in production. It was serving lots of recommendation traffic, but no one quite knew how that model was trained, or right, the lineage of it. So
Yes.
we often run into the issues like this, right? Like there was no notion of any type of experiment management, right? Or even model management, let alone like experiment tracking.
The whole experiment. Yeah.
We have come a long way since then, right? As you said, like often in large organizations or even small organizations, what might happen is that each data scientist or machine learning engineer may be some of the early adopters and champions, right? They may start getting into machine learning and experimenting, doing model training and playing with ML on their say laptop with Jupyter Notebook and so on. But what happens is that doesn't quite scale, right? So especially like when it comes to when we want to deploy the model, and then we want to monitor the model, or we want to understand how this model was even trained, and if you want to reproduce it, if you want to update the model with everything being fixed, but just the training data changed, then when things are done in an ad hoc fashion, it becomes hard to scale or apply like some of the best software engineering like practices, right? Some of the best MLOps practices. So talking of that, what would you consider as some of the best practices in MLOps, and when do you think is the right time for a company to consider adopting such best practices?
Yeah. So yeah, timing, because in the course, right, there are all these workloads that I cover. So even after experiment tracking, there's around evaluation, and evaluation going beyond fine grain, coarse grain, down to slices, and what you define there has downstream impacts on the other places. So what you're doing during evaluation could be very useful when it comes to monitoring, for example, right? So there are all these best practices around testing, monitoring, et cetera. We can talk about each of these, but in terms of timing, I think this is where a lot of teams, especially now, it's so overwhelming, right? You hear about all these best practices, you hear about all these tools you should hear about how you should be robust to scale today, but also scale 5 years from now. And the biggest mistake that I've seen is when teams are adopting things too quickly. And my personal philosophy, and I think there are some differences here with other people as well, but I personally think you should adopt something, whether it's a workload or even specific tooling, when the pain of adopting it is greater than the pain of the current process. And you also need to balance that with what stage your company is in. So we'll talk about that as well. And I had that firsthand coming from a large company to a startup with no resources. So we'll definitely talk about that. But I would say definitely don't be pressured to try to build something that's going to be robust to scale for the next 5 or 10 years. Let's just worry about sort of short term, especially the earlier your company is. And every step of the way, motivate the need for complexity. And this is a big deal, because people always say, what tool should I use? And I think if you're asking yourself that question and you have no idea which direction to go, that usually means you should try something much basic first, right? Much more simpler first. So you understand for your specific context, what are the specific features of a tool in this tooling space that are must-haves for me. So then your decision to actually pick the specific tool you're going to use becomes a lot easier. So these are just like some high level points before I get into timing for each of these. But I think of timing as sort of like a gradient of maturities. And I'm just going to use arbitrary numbers here. I'd love to hear your thoughts on each of these. But let's say you're a team, and you have between 1 to 3 data scientists. No matter what gradient of maturity you're in, you should always work to complete the loop. So it should never be, oh, we're just starting, so we're going to put a lot of effort onto like this one piece. No matter what, make sure you can actually create applications, you can deploy them, and there's some ROI, especially for leadership to be able to see that, and for your own sake as well. But so being able to close the loop and kind of motivating the need for additional complexity when you have between 1 to 3 data scientists, I think must-haves are going to be around what we covered so far. So experiment artifact management. And this larger concept around reproducibility. I think solo data scientist doesn't matter. You need to have this piece. Next, I would say, so you are able to reproduce what you're making. Once you use some data to create, let's say, a model artifact, how do you trust that? So this first layer of trust. So around evaluation/validation as well. And when I say evaluation, I'm talking about evaluating the actual model artifact itself. Maybe it's some behavioral testing, adversarial testing, et cetera, and start small. You don't have to go fully, doesn't have to be super comprehensive yet. And then for validation itself, you should validate your actual inputs into the system. So the data aspect of it, hopefully the code as well, but I'll get to that piece maybe in the next layer of maturity. But definitely the data itself, you should be able to validate what you're putting into the system. So now you've established trust in the input, you're establishing some level of trust on the output as well. And you're starting to build some trust around the whole system. And then obviously the next part, you should absolutely be able to deploy this. And it could be bare bones, especially, and I keep saying, it depends on the context. I'll just make a high level bucket right now. You're either early startup and the data engineering and DevOps teams don't exist, or they're also getting spun up, or you're in a large company where those adjacent teams are mature, but your ML team is early. So in either of these situations, you need to always be able to deploy, but the way you do it might look different. If you're in that first bucket, you may have something very rudimentary, like you wrap your model around an API, deploy it as a standalone microservice. If you're in the latter category, maybe there's already some, like a model server up, or there's something more standardized. But either way, you need to be able to deploy it. And the fourth, I would say, it's ignored. And in the past, it was never easy to ignore, but in the past it was more accepted. Now it's definitely not the way to go. But you need to have a way, even for version 0, 1 to 3 data scientists. You need to have a way of, you've proven the trust during your development. How do you continue to maintain that trust? So some monitoring solution. And we'll talk about build versus buy here, but this is one piece that I think you should never be building. It's great to understand it really well, get into the weeds, but please don't try to build your own monitoring company here, especially for something contextual like this. But yeah, you need to have a solution to be able to maintain what you're putting out there. And when I was at Apple, and all the companies that I work with today, staleness is, I would argue, maybe top 1, but definitely in the top 3 causes of machine learning applications just going away, right? So a core team or an individual develops an application, looks great, they deploy it. Obviously, there's things that happen in the real world that cause this probabilistic system you built to degrade. And what happens is these core teams, they move on to the next project and the project after that. And if there's no way to know what went wrong and no way to know what to do if something does go wrong, then that project dies. And that happens so much even to this day, and it's because there's no solution, or teams have tried to build something custom and they've wasted too much time on it. So this is the first layer of maturity. I'll talk about the next 2 layers, but yeah, curious to see if you're kind of agreeing with, at the base minimum, this is what I see as fundamental.
Yes, I think that's kind of described it in a very nice way, right? Like I think even if there's just one data scientist working on a machine learning project, all the components you mentioned are very essential. Like I want to especially draw the distinction or the difference between doing thorough checking and validation before deployment and continuing to validate and check even after deployment, right? Like monitoring after deployment. Yeah, I think unlike say traditional application software, where say if there is a bug or something is wrong, it will just crash and you get informed or
Yep.
right away. Machine learning models are extremely forgiving, and
Hmm.
even if say, as you said, right, the data becomes stale over time, right? Like the model is not getting the latest data, then the model will still continue making predictions. Or even worse, if somebody goes and changes some units, or some data gets corrupted, maybe some features are unavailable due to some data failure issues, still the model will continue making predictions, just that those predictions will gradually or abruptly degrade over time. And unless we monitor, um, ideally, like the quality of those predictions, in case we have
Hmm.
access to some flavor of ground truth or proxies for ground truth, or
Hmm.
indirect ways, right? We are at the least monitor maybe about data integrity or data distribution, or the probability of the model prediction distribution. We would not, if we don't do those kind of monitorings, we would not have a way of knowing when things go south. It'll go undetected, and often these are the early stages of the machine learning adoption, right? Like the data scientist is making a case
Hmm.
that there is an ROI of machine learning, and for that ROI to translate into a business ROI, it might require maybe a month or a few months. And
Yeah.
during that time, if we don't address all these issues, then the effective ROI may not be much, right? Compared to whatever was the status quo, or a different way of handling things. The machine learning based approach may not demonstrate any improvement.
Yeah. Well said. I think that the silent errors are huge here, and all these checks can help identify at least a subset of them, right? And you'll learn more. And it's like regression testing. You'll continue to add to these suites over time, but start with this, so you have something to build on top of. And I also like that you pointed out this is the minimum for that single solo data scientist, right? You need to have these things in place so you can trust your own work. I guess really quickly I'll cover the kind of in my head the next two layers or gradients of maturities.
So just
So but
one quick
yes, go
comment
ahead.
for our attendees.
Yes.
Please feel free to post any questions you have in the Q&A tab. We would love to take those questions as well, right, as part of this conversation. Yeah, go ahead,
Yeah,
go.
I love that. So between kind of the 3 to 10, the way I envision is you've spent some time in the first category, right? Hopefully you're not hiring like 50 data scientists at once, but you've spent some time in the first category, and hopefully you have some applications out there that are demonstrating some value, and you can see the ROI there. And now I would say it's time to start thinking about standardization, and it translates across all the workflows. So, when it comes to testing, for example, hopefully you did it earlier if you have the luxury of time, but now you should definitely start thinking about testing code itself. And the reason to do this is because, one, for yourself, so you can trust the functions and classes and pieces you're building. But number two, most teams out there, when they get to this size, whether they want to or not, they will start building a central repository. So, a lot of times it starts with pre-processing functions, but also a lot of downstream components where there's shared utility that are shared between all the different types of applications, regardless of the specific modality or anything like that. And as you start to build this central repository that has well tested and validated pieces, it becomes faster and faster for your team to build their next application. So I've seen the best teams kind of maintain this central repository, and testing is a big piece of that. I would also say that standardization around deployment starts getting better. So maybe not everyone's kind of doing their own ad hoc definition of a microservice. Maybe you're moving away from microservices altogether, and there's something more purpose built, like a model server for your team. And it depends again on your size and maturity of, let's say, the DevOps team that's available to help you out. But on the last point that you mentioned, now is definitely the time for monitoring plus, right? So you've covered the artifacts that you're familiar with already, hopefully in the first layer, your inputs, outputs, etc. But now people should start thinking about how can we be a little bit more proactive. And it's very contextual, like you pointed out. If there's no label lag, great. The event that occurred is the label. You can start monitoring right away, and you can create constructs around that. But if there is lag, spend some time designing to see, are there approximate or secondary signals that we can use in the meantime. And I've seen kind of the best teams, even they'll have, whether they have the secondary one or not, they'll start, because it's so core to their product, they'll start having even just small labeling pipelines that run every few days, where a small, well-represented subset of the data is being labeled, not waiting for the entire subset, not waiting for the entire set to be labeled, but a small representative subset, and they'll use that to keep their monitoring in check every few days. And it's not wasted time, because that data is going to be labeled anyway over time. So let's get a small subset labeled as we go, so we can know when it's time to kind of step in and update before degradation hits our core metrics and things like that. So the last stage, I'll just say, it's kind of further building on this, more around automation and standardization.
Maybe if I can add a comment. So
yes, please.
The question I see from George is that in the context of our chat just a few minutes back, are there better quantifications of a model going south, or needing a month or two to demonstrate the ROI, right? Like, are there better ways of so I'm asking this because you just touched upon ways to measure the quality of the model, right? Like, can you just elaborate on like, of course, one approach would be to take a representative but random subset of the production traffic and then label right, get the ground truth via labeling, and then see how the model has performed. What may be other ways of detecting whether there may be issues with the model or the data pipelines?
Yes. So in my head, I split it into two categories. There's things you can do offline before you actually deploy, and then there's things you can do online. So the one we just covered would be an example of something you do online, post-production, etc. Maybe we'll just finish up the online quickly as well. Let's say you already have a system out there. There's a lot of very efficient and clever deployment strategies, right? It's not always a full replace of what's out there. So we have a lesson on, I think it's in the bottom of either systems design or also monitoring itself. But shadow deployments, etc. There's different strategies you can use to try to prove out the value and the superiority of what you're putting out now compared to what already exists. So there's some very nice strategies in the online world. In the offline, definitely around, obviously this in the offline, hopefully you have the labels there already, but what I've seen is full comprehensive evaluation, and the evaluation lesson is also one of the very popular ones. But being able to kind of deep dive into it, right? So you have coarse grain per class, maybe if you have classification, coarse grain and fine grain metrics. But then being able to, let's say, zoom into even a confusion matrix, right? People normally just look at it, but there's a lot of information in there. The false positives could be mislabeled examples. The false negatives could be areas where your model doesn't exactly understand how to, process or be able to understand its representation, for example. So poor performing slices potentially. Creating manual slices on your own data set, whether it's on explicit or implicit or even metadata that you have. So a lot of strategies in the offline and online. But if there is significant label lag, the best solution that I've seen is to get a subset labeled, or you find something very, very closely related that you can use as a proxy for now. But it's easier to say that to just tell you to grab something secondary. A lot of thought needs to go into it.
So if I can add to that, like, I think in addition to monitoring the quality of the model itself, right, in terms of different types of errors, it's also a good idea to just monitor make sure that data integrity issues are monitored, right? Like, because one of the things we find talking to many of our customers is that data integrity is a very common type of issue, like especially in larger organizations, because what the machine learning team may be consuming data that is being generated by a different team, or perhaps multiple streams of data corresponding to different features. And from time to time, the pipelines that generate this data might fail, and the data might become stale, or there may be some corruptions, right, missing values and so forth. So even starting with monitoring of different types of data integrity issues, where missing values or say out of range values, significant change in the difference distribution of the data, each feature and so forth, would often help as well. And similarly, like even monitoring in case, say, we don't have access to any form of ground truth or proxy to ground truth during deployment, even monitoring the distribution of the probabilities generated by the
Mm-hmm.
model often might help. If we start seeing that there's significant change in the distribution of those probabilities, then that may be a cause for concern. Maybe the model is being issued production traffic which has a very different characteristic from that of the data on which it was trained and validated, right? So that might be an so there may
Yep.
be a few such perhaps not ideal but ways of at least monitoring what may be going on, even in case we may not have access to any ground truth at all.
Yep, that's a great point, right? If you can't get the prediction, the performance itself, and use that as the criteria to see if your model's doing well, try to see what else has changed around the input-output space and even intermediate space sometimes. Yeah, that's a great point. I see. Is this the question you just asked, Krishnaram, by Ram?
No, so this is a different one, but we can either take that, or you had this series of thoughts on these different layers of maturity, right? Do you want to just complete
Yeah,
that?
we can.
Go into
Yeah,
that
we'll
one?
complete this one. And this one, it's around monitoring, so maybe we'll discuss it when we get into the later topics as well. But yeah, now, kind of getting to the 10 plus range, and I've seen some teams do this even early on, but I have my personal views on that. But now it's all about reducing deduplication of efforts, and it's about standardization around the different workloads themselves. So, you'll start to see concepts around CI/CD, for example, coming into deployment, and the things that you created before, let's say an evaluation suite, those things are not ad hoc things that you'll run, or it runs during GitHub Actions or something using GitHub Actions. They'll become very concrete triggers for downstream things. Like if this suite passes with, certain criteria, the next thing happens. So just generally concepts around standardization, and specifically the workloads will, being able to orchestrate workloads themselves individually, being able to use CI/CD to have things happen in succession. And the larger concept here is minimal. After the initial development, it's about minimizing the amount of touch that the developers have on each project to continue to keep it maintain it and keep it up to date. So I feel like it comes over time, and you'll build a system that's contextual for your team. But this is also when you start to open up things like continual learning. But until then, it's okay to keep things a little bit ad hoc, but slowly start working towards this kind of standardization. But I'm generally against kind of just starting at this layer, just because you can, because you may not understand all the different pitfalls that may come up from this.
Yes. I think that's a great point. In fact, even for things like continuous learning, right? It's before getting to there, it's a good idea to have all these earlier layers set up, because if we right upfront design the system to be continuously learning, and we don't have all the checks and balances, right? So we don't have the right checks in place. It's quite possible for the model to get into some kind of just feedback loop, right? We see that a lot in the case of bias like issues. We several years back, when Microsoft released a chatbot called Tay, it was a Twitter bot, and it started learning. It was designed to learn from the way people interact with it, and within a span of few hours it started becoming racist and homophobic and so on, right? Like because some people were adversarially trying to manipulate the model. I think in general, like when it comes to something like continuous learning, it's a good idea to make sure that you have the ability to monitor how it's learning, is whether it's learning the way you want, or is there some kind of different types of biases, right? Whether it's demographic or other types of undesirable biases.
Absolutely, that's a great point. And yeah, lessons learned, right? I think with ChatGPT, the team definitely won't be blindly taking all the prompts we've been giving it and using that on the next set. So there's definitely going to be a lot of best practices around validation and monitoring put into that. Yeah.
Yes. So on that note, like let me ask a question from Ram. Could you please identify some strategies for model monitoring and reasons for model degradation? especially when it comes to time series based models. Uh, the context is that there is often delay in getting ground truth for time series models.
Yeah, I think you'd be a better person to answer this, but I think we sort of hit on these points already. The different types of drift on the different artifacts in the system, right? So whether that's the inputs themselves changing, so that you'll see a reason for cause of drift, and hopefully you can measure that very fairly quickly because given your window and given the behavior of the subset you trained with, what should you expect in production? And I think with a lot of time series, there's just in general a lot of concept drift, right? So drift here. So the real world is changing, and if something drastic has happened, the model you developed with the previous data will not be sufficient to deal with this major change that's taken place. So yeah, I would say, I mean, these would be the two main causes. And Krishna, I'd love to hear your views on this. But traditionally, I've seen when something changes drastically with the concept here, teams will usually retrain or develop a new system in place. And when things go back to normal, let's say the COVID example here, when things go back to normal, you can't just kind of continue to use the one that you've created for the interim. So yeah, I'd love to hear your views on this because I personally haven't worked too much with time series. But yeah.
Yes, I think as you kind of touched upon many of these subtleties already. Like I think when it comes to time series models, often again time series itself is a very broad category. There could be models which may be making predictions. Or let's start with something even simpler. There may be models which may be just classification models. Whose input may be time series features, right? Like the features may be changing over time, and the model itself might still be like a typical classification model, right? Maybe even simple logistic regression or random forest-based models and so forth. So that is one type of setting where in that kind of setting, again, like we can monitor. We can continue to monitor all the input features, the distribution of input features. Each feature itself is a kind of like a time series to see whether there are significant changes in the input feature distributions, and similarly like the model predictions. And when it comes to time series, it's often a good idea to take into account different types of seasonality that you may expect in the application. For example, if this is a time series model related to predicting maybe the movies watched by users, then there may be different types of seasonal factors, right? Holidays versus non-holidays, time of the day, and so forth. When it comes to models related to, say, shopping behavior, again, there may be different types of seasonality components. Or if it is a model for predicting some other task, again, like it's a good idea to factor that seasonality, because we don't want to conclude that maybe if some feature is very high during daytime and maybe low during nighttime in a particular time zone, it might just be an artifact of that day and night modality, right? Or weekend and weekday and so forth. So I think that is one type of model. The other type of time series models might be ones where we may want to predict some event, or we may want to predict the amount of items to be stocked up, right? So if it is a supply chain related model, so where we want to make a prediction into the future, and there will be a delay to get the ground truth. Maybe that's what Ram is alluding to, because there's often, once you get to that point of time, now you know the actual value, right? And you can see how good your prediction was. So I think in those settings, again, like there is of course a lag, so you can use the historical predictions made by the model, right? Like taking that lag into account and see whether how the model is performing. The catch though is that you know that if the model is making, say, prediction 30 days from now, you would know exactly how the model has performed up to 30 days back, right? Because 1 month back, you would have made the prediction for
Right, that.
today's data, and you would know how good or how accurate or inaccurate the model is. So I think in those settings, yeah, monitoring may be a little bit challenging. Yeah, there may still be ways to perform other types of monitoring where you may be able to correlate with other time series, right? So if, say, you're predicting the number of items that people will buy uh, 1 month from now, there may be other signals, like before people buy maybe large ticket items, they may be doing some research, and you may get some indirect signals, right? How many views of say maybe large televisions or they have occurred over a period of time, and there may be and those may be an early indicator of the subsequent event, like purchases, which may be a little bit delayed further down. So there may be ways to correlate with other time series information to get, again, kind of like treat them as proxy signals for the true ground truth. And there may be ways to monitor using that. So that's it. I think that there are, if you think of this field of time series models, and whether it is explaining those models or monitoring those models, uh, there is a reasonable amount of academic literature, but still, like when it comes to tools in industry setting, I think there's still a long way to go in terms of maturity of the tools.
Yep, that's fantastic. Actually, I knew you'd have a lot of context on that. Slight tangent, would you recommend incorporating the seasonality and some of these other, like for the views, for example, directly into the model after we learn about it, or is it good to have like different models for different scenarios, or do you think that just depends on the context?
So I would say it depends largely on the context, but it's a good idea to factor in seasonality when we look at these kind of different types of drifts, right? Or for example, if you're even monitoring things like the amount of traffic that the model is getting, and if we also overlay that with even basic seasonality aspects, right? Day and night, nocturnal patterns, and weekend and weekdays, or different holidays in whichever region the model is being deployed, then we would know whether there are abnormal traffic, right? If whether the model is getting unusually high traffic or unusually low traffic on certain days where you expect otherwise, right? I think that's the kind of thing that where incorporating seasonality would definitely help as part of this broader aspect of monitoring of the models.
Yeah, sorry, this is just super interesting to me because it sounds like monitoring is so difficult because it's not just about this little application that you've created right now, and that'll grow and you'll add more things to monitor, but there's so much around the world around your application that's super important. And I'm not sure if for example, Fiddler already does this, but it sounds like I create one. Let's say we both work in the same org. I have a model and I have some artifacts that I'm monitoring. You create a different model and you have some artifacts you're monitoring. It sounds like there's a lot of overlapping or shared things that we both want to monitor that are in the world around both of us. And I just can't imagine doing that ad hoc or in a custom way. Having a tool to do that I feel like you're going to save so much time because there's so many moving pieces.
Yeah, I think that's very true, especially like as the machine learning pipelines become a little bit complex, and they may be, say, it's not at all uncommon at larger organizations for several different teams to have different machine learning models for different tasks, but the underlying data sources may be shared or common, right? So the same feature may be getting used as part of different model pipelines. So say in most cases, it's a good idea to not treat each of these machine learning models in isolation. I think that's all the more reason for having some kind of like a centralized view of all the different models, right? So that way we can know whether is it just a blip, is it just one model behaving in an unusual manner, or is it the case that all the models are having structural issues? It may be also an easier way to diagnose the root causes, right? Is it the case that perhaps this common feature is corrupted. That's why
Hmm.
all these models are getting affected. Or is it the case that maybe everything else is fine, but just one model is problematic for various reasons, right? So I think
Yeah.
that's the reason why instead of viewing each team or each individual looking at things in isolation, like having a little bit of unified view of what's happening across the entire organization,
Hmm.
it's also helpful. Like that might also give us early indicator of, especially as these models have impact on downstream business impact, early indicators when something is not going as expected.
Hmm. Yeah.
Let me ask another question that I see from David. Um,
Yeah.
how do you deal with so many MLOps related technologies that are arising every day? In other words, how do you usually filter out the tools worth checking and the ones not so good that just follow the current trends?
Oh, yeah. That's a great question, David. And I think there's so many aspects to it that we can talk about. Maybe I'll start with the easiest bit, and then we'll dive in. Just the other day, Krishna Ram and I were talking about just end to end versus best of breed, right? So even that concept opens up the question of what do you want to use tooling for, and how encompassing do you want that tool to be? Like how many of the workloads do you want it to manage? And then also like the degree in which you want to maintain control. Do you want something that just works more of a black box, or do you want something where it's super bare bones that you're kind of doing every single piece of it, like a bare bones on top of bare bones Kubernetes or something? So it depends on a lot of pieces. But I'll start like me personally when I look at a tool in the startup and Apple before that, but back then the landscape was not as mature. It's so important to know the jobs to be done when you're building out an application. Um, and I say building out an application because there's some immediate things that's on top of mind for you. So if there's a great new tool that comes out for managing and feature open source feature stores or something like that, and you don't need it, first of all, if you don't need it, you should be. It's good to like keep in your head and learn about it, but don't spend too much time, and certainly don't implement it in a scenario where you don't need it. But let's say it's something you need downstream. It's good to know about it, but until you motivated the need for it and it's a job that needs to be done, I would say don't spend time beyond the cursory kind of look to understand how it works. Don't try to start implementing it. So for me personally, I have a certain set of jobs to be done, and I look at the tools that are available to do that. And I would say the most complicated thing, and I think you hit this on your question, so many tools have so many overlaps, right? They're either they're in the exact same, they're both point solutions for the exact same part of the workflow, let's say like a labeling solution or experiment tracking. Then it becomes difficult because there's so many overlapping. And in the other case, there could be two different entry points where a lot of people are starting to go end to end these days. They may start as a point solution, but either as a result of investment or whatever it is, they're starting to cover other parts of the MLOps lifecycle. That's also difficult because they started with different advantages, but now they're starting to take over different aspects of the workloads. But yeah, again, I would say like going back to the jobs to be done, what are for example, the point solutions that are heavily overlapped. If you know what needs to be done, and if you know what features you need, so start with the features you need, not the features that they have. If you know what features you need, this becomes so much easier, and to actually say, hey, I think this is maybe not the one to go with right away, but this is the one we should spend our time testing, or actually even having a conversation with, because they have this core feature it's a game changer for us, and we need to have it. So yeah, that's my view on it, but it's such a big question, right? It's like how much responsibility you want to have. Yeah, and unfortunately, I think finances are also part of it if you're an early stage startup. But there's some things that you shouldn't be building. So yeah, I'd love to hear Krishna Ram's view on this too, because I know we were touching on it last time.
Yes, thanks, Goku. So I think as you kind of touched upon, right, there's always this question of do we go for an end-to-end solution, or do we want the best of breed, right, in terms of contextual machine learning stacks, or is there a middle ground? Like what we hear from customers is that often there are different types of trade-offs, right? Like some customers might want to deal with fewer vendors instead of more vendors, so that might kind of make a case for end-to-end solution. The challenge though is that the end-to-end solution might cover all aspects of the machine learning MLOps pipeline, but might provide just the basic functionality. So that is the reason we see customers often gravitating towards the best of the breed, right? Like when it comes to each of these different stages of the machine learning pipeline, whether it is say experiment tracking, feature stores, or like A/B testing or monitoring of the models and so forth. So one of the things that we see sometimes helping is that often, especially in mid to large sized organizations, the customers might have a pre-approved budget for let's say there is a pre-approved budget for AWS marketplace. Then the fact that a vendor is part of that marketplace seems to simplify a lot. Like for instance, in our case, Fiddler is part of the AWS marketplace, and so that means that they don't have to again go through if they're already using AWS, they have a pre-approved budget to use from AWS. They don't necessarily have to again go through a separate approval process and the bureaucratic process to get approval for budget requests from each of the different vendors. The other aspect we see is that, so this is a little bit from a more like a logistical or operational angle, right? What I described so far. But on the other hand, as we discussed earlier, the machine learning data science initiatives are often very much evolving in a decentralized fashion. Because again, there may be different teams, might be at different levels of maturity, and there may be different data scientists. Maybe some may be early adopters of new technologies, right? So as a result, what often happens is that they may tend to use tools from even different cloud providers. So because of this decentralized way of how things evolve, in those cases, the end-to-end may not even make sense, because like if say one team is using AWS machine learning setup, like say SageMaker or EKS and so forth, and another team is Azure ML based stack, yet another team is using say GCP, then there is no single end-to-end solution. And in those cases, we do see the benefit of the customers leveraging tools, right, that, which provide a centralized view of all the different machine learning pipelines happening across even different cloud providers. Even from apart from this kind of bottom-up aspect, right? Sometimes large companies also tend to like mitigate some flavor of risk. They don't want to go with just a single cloud provider. They intentionally want not too much dependence on a single cloud. So in that case, again, we see that different parts of the org might be using different cloud providers. And again, like having a centralized monitoring tool in that case seems to help such customers.
Yep. And what I'm hearing is try to leverage the trust that a certain tool is already built with the community, with other kind of industry partners. And then certainly these larger platforms like SageMaker, for example, who make it easier for you to integrate. And that integration point is huge, right? Because we think these tools exist, easy to stitch together. It's not, right? So it's best to kind of work with tools that have proven themselves and are trusted, and it's worth the initial overhead, for example, that you may have to go through. Hey, Krishna, I know we have you guys have like some other questions and stuff, but the question that Ram asked right now, I feel touches on a lot of things that I think we wanted to talk about as well. But Ram was.
Yes. So before that, just a quick comment. I think one of since you brought up SageMaker, that Amazon SageMaker, one of the things that I have seen even Amazon SageMaker evolve over the years, having worked on some of the SageMaker components while XML, is that even end-to-end platforms like SageMaker have realized that they go where the customers want, right? So they have made it easy to integrate with best of breed tools, so that a customer might be using SageMaker for, say, training and inference, but they may use a specific tool for monitoring, or they may use a specific tool for feature store or experiment tracking, right? Which may not be the SageMaker's native tool. So again, that is a thing we see evolving more and more. So shall I just ask the
Yes.
question from Ram? So for the purpose of recording, so quite often we see data scientists moving on from one use case to another use case after they hand over the model artifacts to machine learning engineers for scalability purposes. Sometimes these ML engineers may not have full context after a year or so, especially when you hit the times like COVID. Did you come across any tools or solutions that have developed this intuition and can provide prescriptive guidance about retraining or retuning the model depending on the current context?
Yeah, and I think this question encapsulates one of the biggest kind of concepts around best practices that's evolving right now. And I'm going to give the easy answer, Ram, and this is one big thing that I had for Krishna Ram and the Fiddler team as well. But right now, the best I've seen that I've done, that amazing teams have done, is documentation, which I know is a cop-out answer, but you need to be able to document a lot of what you're doing along the way. And there's so many tools now that make that easier, that doesn't feel like a separate workload that you have to do. So for example, when we're talking about data validation, or we're talking about monitoring, or we're talking about even scripting around your code and testing, a lot of these tools generate documentation automatically around how things are designed, why it's designed, descriptions below each one, etc. But for the more, let's call it like contextual workflows, like when to retrain, what to do when something goes wrong, like a playbook of sorts, documentation is going to be the best. And playbook is something that people can follow. That's the best I've seen so far. But the question that I've been asking myself and teams that I work with is, who should be creating this playbook, if you will, and who should be creating this in V0, and who should be responsible for maintaining this? And something very evolving like monitoring. I personally think the core team that's there developing V0, V1, they should be defining the initial set of things. But right now, as you mentioned, these core teams are very valuable and they're working on a lot of different things, different projects. They're going to jump to the next project. My big question is, will there something similar to a SRE team, right, from Software 1.0, will that evolve for our space here? Or will the amount of debt, if you will, keep piling up for these core teams? That's kind of a big question in my head. Or will there be kind of a new role even defined? But yeah, I'd love to hear, from your personal experience and as a company that you guys have seen, who should be creating and maintaining these, specifically around monitoring, right? Because that's where a lot of the work is afterwards. That's why you're using a tool.
Yes, I think that is a great question, and great, thanks for that, sharing your experiences. So I would say that at least from what I have seen, different companies seem to follow different approaches, right? Like for example, when I was at LinkedIn, there was a SRE team, and this team was responsible for all the live incidents, right, related to even things like scaling up of the model and monitoring or taking care of the production cluster where the models were deployed and so on. But the scientists, the research scientists and engineers who were developing the models were still often on call, right? The model was it's not like a handover approach, and these scientists would be owning the REST APIs at LinkedIn, and if say there is some issue with the quality, then they will go and identify the root causes. In some companies, it's a different model, like what I think Ram was alluding to. The data scientist might develop the model, and then there is some other team, ML engineer, which is handling the productionization and maintenance of the model. I think in those cases, as you said, documentation is super important. It cannot be stressed enough. how to even reproduce, what are the assumptions that went into this. I would say that one of the things that the community is moving towards is this notion of model cards or system cards and so forth, which is like, how was this model developed? What are the data sets used? What are the limitations? What are the intended use cases? And for what purposes should this model be used, and for what purposes it should not be used, and so on, right? All those things become extremely important. Otherwise, like, you may develop a model with some assumptions in mind, and then the model may end up getting used for a completely different purpose, and it may start exhibiting all kinds of issues, right, including demographic biases and whatnot.
Yeah, absolutely. One more thing I just wanted to add to that. So documentation model cards, these are great for people who, either yourself or somebody else in your team, to quickly get back to that level of thinking you had when you were developing it for the first time. And then in the production scenario, as Krishna mentioned earlier, it's so important to monitor these things right away, because when something goes wrong, even if you have this context and you quickly caught up, knowing what went wrong, right? Being able to do like a root cause analysis here, you do not want to lose time there. So kind of having the proper setup around the post-deployment piece will also help here. And the reason, the main reason this question is being asked is, how do we fix this issue if there is an issue, and how do we update or iterate, and how do we get back to what we were working on before? So it's about reducing that time to update this or fix it. So I think both of these pieces are very crucial.
Yes, I think that's a great point. Reducing anything that you can do to reduce the time to detect the issues and then fix the issues, I think that saves the engineer or scientist productivity, and kind of also reduces the amount of business impact or damage, right?
Yes.
So with that note, I think we're just over time. So it was a great conversation. We could go on for another hour.
Easily.
Let me thank all the attendees for joining today, and those who may be watching this recording afterwards. And of course, a great thanks to Goku for joining us today and making this very inspiring conversation.
Yeah, thank you so much, everyone. Yeah, we can easily talk for several more hours, but yeah, hope to be back, and definitely for in-person events too. I think that would be awesome for the community as well. But yeah, thank you guys, and thank you for building such an amazing product, because it's something that I always think people should be using something that's already built out there. It's very time consuming and it's very contextual, right? So people should definitely, I think it's amazing that such a product exists. So thanks to you, Krishnaram, and the rest of the team as well.
Thanks, Goku. Thanks all.
Thank you.